The first function is linear function with the parent equation y equals x.
To find the type of symmetry, plug in negative x for all x's. For an odd equation, when negative x is plugged in, it will be the opposite of the original function. And if it is even, then the new function will be the same as the original. For y equals x, when negative x is plugged into x, the new function is y equals negative x, which is the opposite of y equals x, indicating an odd function.
The function is unbounded since it stretches forever in both directions. There are no asymptotes. The function is increasing from negative infinity to positive infinity. Increasing and decreasing is measured from left to right, and since all values continue to increase positively, there is no decrease. There are no extremas, and it is a continuous function.
The domain is from negative infinity to positive infinity because there are no restrictions. If there were restrictions, they could include a denominator which cannot be equal to 0, or a square root which can't be negative. The range is also from negative infinity to positive infinity. For n behavior, as x approaches negative infinity, y approaches negative infinity, since the y values keep getting smaller as x goes further to the left. As x approaches positive infinity, y also approaches positive infinity, since the y values continue to get larger towards the right. The second function is a quadratic with the parent equation of y equals x squared.
For symmetry, when negative x is plugged into the equation, y is still equal to x squared, meaning that the function is even. There are no asymptotes. The function is bounded below since there is an absolute minimum.
The function is decreasing from negative infinity to 0. The function is increasing from 0 to positive infinity, since the point 0, 0 is the minimum, and also serves as the turning point for the equation. There is an absolute minimum of 0 when x is 0, since that is a minimum of the function, and both ends continue to stretch towards the positive numbers.
The function is continuous. Domain is from negative infinity to positive infinity since there are no restrictions. The range is from 0 to positive infinity, which can be seen from the graph, and also because the minimum y value is at 0. For the end behavior, as x approaches negative infinity and y approaches positive infinity, since y values keep increasing forever, and the same thing occurs as x approaches positive infinity.
So for the domain and range of the cubic function, it's negative infinity to positive infinity because the function continues unhindered from negative to positive infinity.
The function is an odd function because when the opposite of x is cubed, is taken, it's the opposite of the original function.
The cubic function is unbounded and it does not have any asymptotes nor discontinuities. The end behavior is, as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y also approaches negative infinity.
The function does not have a local maximum or minimum. It is increasing from negative infinity to positive infinity.
Inverse linear function. The domain and range of this function are the same, negative infinity to 0 and 0 to positive infinity. This is because the function has a horizontal and vertical asymptote, both at 0, that the function cannot cross.
The inverse linear function is not bounded and has infinite discontinuity at x equals 0 that is non-removable.
This function is an odd function because when the opposite x is evaluated, it is the opposite of the original function.
This function is decreasing from 0 to negative infinity and also decreasing from 0 to infinity. There are no extremas. The end behavior of this function is as x approaches to positive and negative infinity and y approaches 0.
Parent function 5 is a square root function.
As you can see, it starts at the origin 0, 0, and then increases exponentially.
The domain of the function is including 0 to infinity, and the range is also including 0 to infinity.
It has no symmetry, and it is bounded below since it cannot reach the negative infinity range.
There are no asymptotes and no discontinuities.
The function increases from 0 to infinity, and there is no portion where it decreases.
There is an absolute minimum of 0 at x equals 0, which is our extreme.
For the end behavior, as x approaches infinity, the y's approach infinity, and as x approaches negative infinity, it does not exist.
So we had the exponential functions. So basically, when the b, which is the base of an exponential function, is more than 1, it represents an exponential growth, like this graph right here, which has a base of 2. When the base is between 0 and 1, it represents an exponential decay, like this graph right here, which has a base of 1/2. Both functions are to the exponent of x.
The domain of function 1 and 2 are negative infinity to infinity, and the range of function 1 and 2 are 0 to infinity. There is no symmetry because if you flip the function over the x or the y-axis, it won't perfectly flip on itself.
Both function 1 and function 2 have the horizontal asymptote of y equals 0 and no vertical asymptote. The asymptote restricts the range of both functions, causing them to be bounded below because they cannot reach negative infinity.
On this graph, there are no holes and no breaks in the continuous line. Therefore, there are no discontinuities. On the first graph, from negative infinity to positive infinity, the y values are increasing continuously. While on the second graph, from negative infinity to positive infinity, the y values are continuously decreasing.
There are no extrema. The end behavior for f of x equals 2 to the power of x as x approaches negative infinity is 0, because there is a horizontal asymptote at y equals 0. As it approaches infinity, the end behavior is infinity. For f of x equals 1/2 to the power of x, the end behavior as x approaches negative infinity is infinity. And as x approaches infinity, y approaches 0.
Hi! Our group has the parent function of f of x equals log base b of x. It models how I sleep, just like a log. The domain goes from 0 to infinity, and the range goes all the way from negative infinity to infinity.
Exciting stuff right there, Coop. The symmetry of our function is a amount of subjects that are colored in PreCalc. None. There are also no bounds to the function, just like there are no limits to the amount of fun PreCalc is.
Wow, I had no idea. The function has one vertical asymptote of x equals 0. However, there are no discontinuities. I guess it likes to just keep going.
Interesting facts. The function never decreases but only increases from 0 to infinity. There are no extremas.
The only appropriate way to end our video is to discuss end behavior. There is no end behavior as x approaches negative infinity, but as x approaches infinity, the function goes towards infinity too. Thanks for learning along with us about logs.
For parent function 8, it's an absolute value function.
The domain of the function is negative infinity to infinity, while the range is 0 to infinity.
The symmetry is even because if you plug in negative x, it still equals the absolute value of x.
It is bounded below, and it will never be able to reach the negative infinity range.
There are no asymptotes and no discontinuities.
The function is decreasing from negative infinity to 0, and it is increasing from 0 to infinity.
For extrema, there is an absolute minimum of 0 at x equals 0.
The end behavior is as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity.
The greatest integer function is a function that includes all of the integers of x. The domain in all real numbers, and the range is the set. So the domain is all of the real numbers, and the range is the set of all integers. This function has a lot of different ways to be written. The y integer is the parent function that you use on your calculator. Y floor of x is another way to rewrite the function that you use on Desmos. The y absolute value of function of x is taken from the textbook. The greatest integer functions do not have symmetry, boundedness, asymptotes, or extrema. This function is constant on each step, not increasing nor decreasing.
Hello,
The parent function is a logistic function. The equation is f of x equals 1 over 1 plus e to the negative x power.
The domain is negative infinity to infinity, and the range is 0 to 1, as represented by the graph. There is no symmetry, and it is bounded on the top and bottom.
There are two horizontal asymptotes. One is at y equals 1, and the other is at y equals 0. There are no discontinuities.
It is increasing from negative infinity to infinity, and there are no extrema. The end behavior as x approaches infinity, y approaches 1, and as x approaches negative infinity, y approaches 0.
Thank you.
Parent function 11 is the sine function, which is y equals sine of x. This is what the function looks like on the graph. Notice how the x-axis intervals are labeled with pi. First, the symmetry is odd because you can take any point and flip it over the x and y-axis, which will result in the new point being in the same location as another point on the graph.
Second, the boundedness is bounded above and below. This function has no asymptotes and no discontinuities. End behavior is D and E, which means does not exist since the pattern keeps repeating. For the extrema, it has multiple absolute minimums and maximums. The absolute maximum has a y value of 1 and reaches that point many times. An example of one of the x values where the graph is at its maximum is pi over 2. And it repeats every 2 pi. The way we write this is absolute maximum of 1 at pi over 2 plus 2 pi k, where k represents any whole integer. We write the absolute minimum in the same way, but the y value is negative 1 and the x is negative pi over 2.
The domain goes from negative infinity to infinity, and the range goes from negative 1 to 1. There are no intervals for increasing or decreasing because the function is oscillating.
Hello. Our equation is y equals cosine of x. Here's the graph of it, and its symmetry is even. This graph is bounded above and below and has no asymptotes.
Okay. This graph is has no discontinuities, and its absolute max is at x equals 0 plus 2 pi plus k. Its absolute min is at when pi plus 2 pi times k.
The domain of this graph is from negative infinity to infinity, and the range is from negative 1 to 1.
For this graph's end behavior, as the x values decrease, the y values do not exceed 1 and negative 1. As the x values increase, the same thing happens. This is an oscillating function.